So we are going live now. So just indicate to me if you can hear me, all of you. If I'm audible, please indicate to me that I'm audible. If I'm audible, please let me know that I'm audible and I'll start. All right. So good evening, all of you. Welcome to this live by Pathfinderforme. And as you are aware, we do these lives every week on Friday and Saturday. And these lives are generally on topics that are around CAT. So today we are going to do questions related to set theory. Now, set theory questions have appeared in CAT and allied MBA entrance exams with a regular frequency. बहुत regularly questions आए हैं. 3 set, 4 set तक के questions आए हैं. And today, since this is the first session on set theory, we are going to focus on questions related to 3 sets. In the next class, that will be next Friday, we will focus on questions that are related to 4 sets. But first, before we start, let's try to understand a few things about set theory, and I hope you're already aware of these things. Number one, when two sets intersect A and B, we have A union B is equal to, in fact, I should write it this way, number of elements in A plus number of elements in B minus number of elements in A intersection B. This is the first thing you ought to know. And what is A intersection B? The shaded portion is A intersection B. If there are 3 sets like this, ABC, please remember number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in A intersection B minus number of elements in B intersection C plus number of elements in A intersection B intersection C. And see, what is A intersection B? A intersection B will be this whole area that I shade in yellow. This whole area is A intersection B. Okay. And what about A intersection C? So the shaded area in red will be A intersection C. And what about A intersection B intersection C? The green area in the middle is A intersection B intersection C. So this is something you need to understand while solving, or you need to know while solving questions based on set theory. So with this background, because we cannot go into the depth of teaching for all this, we have already covered this in the class. We'll go to questions which have appeared in CAT based on this concept. Okay. So let us have a look at the first 2 questions. In fact, these questions appear always in the form of a caselet. You can see this. And let me just pull out my stopwatch here. Yeah, stopwatch is there. Let me minimize this. I'll give you 5 minutes to solve this question, not more than 5 minutes. And your time starts now. Please begin. Please begin. Your time has started. I guess I did not switch on the. I think my voice was not audible all this while. And none of you told me also. Despite
No,
the
sir,
fact
it
that
was audible.
Okay, fine.
Yes, sir.
Okay, someone already has an answer. Rachi says 1D. Okay, very good, Rachi. Rachi, I'm not sure if it is C. Okay, how many of you have got it? Anyone apart from Rachi? Okay, last 40 seconds. I'm not sure, Srijan, if you're still there, but I hope you're solving it. Okay, time is up. So some of you have tried to answer. There are 100 schools in a town. Out of these, the number of schools having a playground was 30. And these schools neither had library or laboratory. So we know that there are three things. So what we'll immediately do is we'll draw a Venn diagram with three circles, each circle indicating something. So let's say this is a circle of playground. This one. This is a circle of laboratory. So let us say circle of lab. And this is a circle of library. So you're told the number of schools having a playground was 30. So obviously the part covered by the circle of playground is 30. So all the elements of playground are 30. But you're told that these schools neither had library nor laboratory. So none of these 30 are common with laboratory wala schools or library wala schools. So you know for sure that these schools must have playground alone. So we got the first part. 30 schools have only playground. Then the number of schools having a laboratory alone was twice the number of schools having a library alone. So let's say library alone is X schools. So laboratory alone must be 2X schools because it's given there. And the number of schools having laboratory and library. So this whole, the shaded portion. Actually, there is nothing common in the three. There is nothing common here because no school has all the three. Because the schools with playground has only playground. So this part is how much? Is 1/4 the number of schools having lab alone. So 2x by 4, that will be x by 2. And now you're said the number of schools having either a laboratory or a library or both. So either a laboratory or a library or both. That means 2x plus x by 2 is equal to 35. And what do you have? X is equal to 10. So which means these values, let me write in terms of x 10, 20, and this must be 5. Now what is asked? How many schools have none of the three? Now total 100 schools were there. Out of 100, you have 20, 30, 50, 10, 60, and 5. 65 schools has at least one of the three: playground, laboratory, and library. So obviously 35 schools had nothing. Then what is the ratio of schools having lab to library? Now lab, the number of schools is 20 plus 5. So number of schools having lab is 25. I'll write it here. And number of schools having library is 10 plus 5, 15. So what is the ratio? 25 is to 15, which must be 5 is to 3. Very easy question. This is an old CAT question. And as I told you, we will warm up slowly. It's still some months to CAT. So we are starting off with relatively easy questions, relatively older questions of CAT, which have 3 sets alone. In the next class, we will cover certain questions which are based on 4 sets. That is next Friday. So I hope this explanation was clear. If it is clear, give me a thumbs up. Those of you who are watching this on Zoom, please give me a thumbs up. And if you're watching this on YouTube, please give me a like at least. एक like बनता है. And if you understood, you could just indicate there in the comment box or in the chat box. Chalo, let us go to the next one. Thank you. Another old CAT question only. So again, I'll give you 5 minutes to solve this question, not more than 5 minutes, not required. You won't require more than 5. In fact, even 5 minutes is more for this question. So your time starts now. Let's try to solve this in 4 minutes itself. Okay, some of you are giving the answers now. Good. Last 15 seconds. Okay, so I can see that some of you have given me the right answer. Very good. 85 children went to an amusement park where they could ride on the merry-go-round, roller coaster, and Ferris wheel. So once again, there are three items. So you have your three circles here, 1, 2, and 3. So let us name them merry-go-round, roller coaster, and Ferris wheel. It was known that 20 of them took all the three rides. So I'll write this as 20. Let me write it out in red. So they took all the three rides, and 55 of them took at least two of the three rides. So suppose D, E, and F, these are regions for exactly two rides. And 55 is the number of them who took at least two of the three rides. At least two means two or three rides. So out of 55, 20 have taken three rides. So 55 minus 20, 35 would have taken exactly two rides. This is the first thing you've got to calculate. Now see, if anybody has taken three rides, 20 students, 20 children have taken three rides. So for each of them 3 rupees, because the cost of each ride was 1 rupee. Similarly, 35 students have taken two rides each. So cost will be 35 into 2, 70. And let us say X students have taken one ride, and the total must be equal to 145. So 60 plus 70, 130. So X is equal to 15, which means the number of students who have taken one ride exactly is 15. So fourth one is done. Now see, out of 85 students, 35 took two rides. These 35. 20 took all the three rides and 15 took exactly one ride. What is the total number of students who took any ride? 55 plus 15, 70. So what is the number of children who did not take any ride? That is 15, which must be your answer. If you understood the solution, please give me a thumbs up. If you understood the solution, please give me a thumbs up. Yeah, thank you. Let us go to the next question. And this is a relatively, even this is an old CAT only. But of the three questions, this I feel is the toughest today, but not very tough. This is also moderately tough, and that's why I've labeled the sheet as moderately tough. So as we proceed, we will look at tougher questions. So you have 4 minutes for this question. Your time starts now. Please begin. Okay, how many of you have done it? Okay, I have not received any answers this time. Never mind. Let's see. New age consultants. Okay, somebody has given an answer. Fifth is D. Prathamesh says D. Okay, let's see, Prathamesh. New age consultants have three consultants: Jnani, Buddhi, and Medha. So once again, there are three. You have Jnani, G. You have Buddhi, and you have Medha. The sum of number of projects were handled by Jnani and Buddhi individually is equal to the number of projects in which Medha is involved. Now, this is a tricky sentence, right? Sum of projects handled by Jnani and Buddhi individually. What does that mean? What does that mean to you? Anyone? So here, the sentence basically is telling you that if Jnani has handled alone, all alone, G projects, and Buddhi has handled all alone B projects, the total number of projects handled by Medha is G plus B, right? So I can say this must be equal to G plus B, where G is the number of projects handled by Jnani alone, and B is the number of projects handled by Buddhi alone. All the three consultants are involved in 6 projects together, so this is 6. Jnani works with Medha on 14 projects. So Jnani and Medha, this region, is 14 projects. Out of these 6, all the 3 are working. So 8, only Jnani and Medha are working, but not Buddhi. Buddhi has 2 projects with Medha, but without Jnani. Buddhi has 2 projects with Medha without Jnani, and 3 projects with Jnani but without Medha. Now we have filled the central section now. The total number of projects with new age consultants is 1 less than twice the number of projects in which more than one consultant is involved. So how many projects in which more than one consultant is involved? How many projects are there? These numbers 3, 6, 9, 8 and 2. Sorry, 3, 6, 8 and 2. 3, 6, 9, 8, 17 and 2, 19. So the total projects is 1 less than twice this number. So obviously the total projects must be 19 into 2 minus 1. That is 37 projects. Right? Now, if 37 projects is the total number, you will appreciate here that 37 must be the sum total of all these numbers. Right? So G plus B plus G plus B. Are you able to understand this? G plus B
Yes, sir.
plus 3, 6, 8, 2 and G plus B. This is equal to 37. Let us call this number as X. Now what happens? 37 must be equal to G plus B plus X plus 3, 6, 9, 8, 17 to 19. So what do you get? What do you get here? You get G plus B plus X is equal to 18. Yeah. G plus B plus X is equal to 18. And what is X? X is basically M minus 8 plus 6 plus 2. M minus 8 plus 6 plus 2. What does it mean to you? What does this mean to you? Does it mean anything to you? Hmm? See, what is the value of G plus B? Anyone who can give me the value of G plus B? Anyone who can give me a value of G plus B?
14 plus x, sorry, 16 plus x.
How?
So the sentence, the sum of number of projects handled by Gyani and Vidhi
No, see,
individually.
G plus B is 8 plus 6 plus 2 plus X. Do you agree? G plus B is equal to 8 plus 6 plus 2 plus X. This part you all agree? Yes or no? See, G plus B is the number of projects in which Medha is involved, which is 8, 6, 14 to 16 plus X. So I have G plus B is 16 plus X. So in this equation, I can write G plus B as 16 plus X. So 16 plus X is equal to 18. So 16 plus 2X is equal to 18. So X must be equal to 1. So number of projects handled alone by Medha is 1. Which means we have an answer for question number 6. Yes. And what about G plus B? Although I have the value of X, but I have the total value of G plus B. I don't have individually the values of G or B. So what is the number of projects in which Gyani alone is involved? You can't say. What is the number of projects in which Buddhi alone is involved? Again, you can't say. So it cannot be determined uniquely. Is the solution clear to you?
Yes, sir.
If it is clear, give me a thumbs up. Yeah. So see, set theory is a very interesting topic, and questions based on set theory appear in CAT with regular frequency. Mind you, every 2-3 years, you will have questions of set theory. And generally, these questions don't appear in, you won't see one question. It will be either 2 or 3 questions. And the best part is you can find these questions in either quantitative aptitude section, or you can also find a question based on sets in DI and LR. It's a very, very important topic from the perspective of CAT. Please make sure that you always, you always prepare very well on sets. And if you're here for the first time, join us for the next class on sets, which will be based on 4 sets. So today we had a class on 3 sets. The next Friday, we are going to have a class which is based on 4 sets. And tomorrow we are going to have a class based on data interpretation. So join us for the lives on Fridays and Saturday, every Friday, every Saturday at 6:30 p.m. I thank you all for joining me today. And I will end the stream now. Thank you very much. Thanks for joining. Zoom वाले 2 मिनट रुकना भाई.